So every morning when I wake up, I usually turn on my laptop, get a coffee, and start reading a lot of articles from the various newsletters I'm subscribed to, mostly in the domain of AI and technology. And usually there are a lot of articles saying like this company or that research center published paper on X, Y, or Z, or created proof of concept on some of the breakthrough research aspects. And from time to time, I get extremely excited. Like, wow, I would like to have that in my phone. It will help me so much. Then when I reflect back and look at some previous examples, I become a bit sad because I know this will not be available on my phone in some version of an application or a feature, probably in a year, probably even 2 years. So today I want to talk about this topic of how can we bridge the gap between AI research or in general like any demo of proof of concept and making it work at scale in production with humans in the center, meaning it should be working for us as a humans. And there are wide spectrum of things that we'll cover today, from like deep technical conundrums all the way to like values and meanings, because with AI we will revolutionize what some of these aspects in our day-to-day life means. So thank you all for coming. It's great to be here, and definitely looking forward to all the follow-up conversation that we can handle this topic. So let me start with why, as this is very important that we, whatever we do, we start with that question, like why should you care? Depending how you count, there were a few technological revolutions before, and we are at the beginning of the new one, and AI is spearheading this technology revolution. Whether you think of AI as a new electricity or whatnot, we definitely see that how AI and machine learning is working is definitely changing, and it's essentially, we can think of it as a catalyst of some seismic changes that we are going to see. Now, we all know, like at the beginning, like the focus was more on traditional programming, meaning software engineers are building the rules that for desire, like for the given input, produce the desired outcome. With machine learning is a bit different. We give data in some like input output format, and then machine learning creates these rules. As we heard on previous talk, a lot of these things are still black box, meaning it's not that interpretable by us humans, but we see a huge things happening because with this approach, it's not only that we are opening doors which were previously closed, they were even locked. So we are automating a lot of things and even starting to build things that will help us satisfy some of the unmet previous needs that we had as a humankind. And when you look at the product, there is also a very clear trend, and a bit funny if you think about it. Like there is a trend that a lot of code is being replaced by machine learning models. Algorithms are essentially optimization kind of function. You want to optimize for some high some downstream task, like from trivial things like sorting an array to, I don't know, product recommendation or object detection. So these are optimization function. Machine learning is much better in doing that, not only in terms of quality, but also in terms of adapting and maintaining to based on the new trends and human needs. And as depicted on this picture, we are only at the beginning, but this beginning is very interesting because we are entering a stage where AI is in inflection point, meaning that a lot of layers of abstraction are happening here, so that wider base of people or roles in the business or consumers are being able to understand what's happening and build their own solution. Like similar in programming, like 40 years ago, you needed to understand what's happening on a hardware level. And now today you have a bunch of APIs, bunch of SDKs that you can build and just not knowing, not even need to understand what's happening on a lower level. Similar is for AI. So this is all good. Now the question is, Andrea, what's the problem? We also heard on a previous talk that yes, depending like which analysis you read, you might get different numbers. But any analysis is showing, I'm here quoting, I think, Gartner one, that majority of these AI products don't hit production. And even the ones that do, they're not profitable, essentially meaning they are not satisfying some of our human needs. So this AI concept moving to production essentially means that usually we have some happy path and we get very excited about having that happy path working, but moving that to production, especially having this technology, the pace of innovation and disruptance in how we live and how we work brings a lot of challenges. So in order to paint the picture, here is I will just reference one of these examples so that we can easily understand the complexity. And healthcare is always a good example that we can all relate to. There are a bunch of papers in various fields saying that like AI systems can perform on par or even better with some healthcare workers. I picked an example of AI system finding pathologies based on the X-ray images, and there are a lot of these kind of titles of papers, and they're all true. They're true. They're well-written papers, peer-reviewed, domain experts working on those papers as well. But the last time you went to the doctor, I'm sure that your doctor did not use AI system to make a decision. Now, why is that? We will learn through this talk a few things, but essentially it boils down to various kind of things about the trust, building credibility, or even fairness. Like in this particular example, when you double click what our achieve radiologist level performance even means, it's much more simpler. There is a benchmark data, like pairs of images and their labels, and then we build the model, and then performance, average performance of the whole set, we calculate that, precision, recall, whatever we want to do, and then we have, okay, this is human level performance, and then we compare those two numbers. Now, the tricky part is that in this particular example, these AI systems work perfectly for things like pneumonia. But then there is a subset, like hernia, where it's basically flip of a coin for AI. And for research, when you zoom out and you look at average performance, it's still 99 point whatever, but it's simply not acceptable that we push this to production when we know there is a group of people that for which this will not work or even make potential damages. I will talk about this, another example in the following slides, but again, we all heard about various generative models from images, text, OpenAI, probably the most famous one, but still, we don't see this in all of our day-to-day applications. You pick your mobile phone, I doubt you have an application or maybe one which is using some of these. So in short, why is this the case? Well, it's goddamn hard to do it. And as depicted in this visualization, moving from this happy path, like proof of concept, to scale, there are a lot of things that we need to cover. Now, I don't have the answer for this, of course, so let me walk you through a few examples that my team and I was working in the past few years, which will hopefully help you understand some of the complexities, but still this will be scratching the surface. Okay, so using this example, I want to talk about user experience. So here is an example of a feature called data from picture, which we shipped in Excel. You can take a picture of a photo or a screenshot from your machine, and then we will extract the data from that table and generate the editable Excel spreadsheet for you. So you have scanner in your pocket, essentially. Now, there is something called generalization and robustness in machine learning. And generalization and robustness means how is your model performing on previously unseen examples or noisy examples or outliers. So when it comes to digitization, we are doing optical graph character recognition for like a lot of years now, so this shouldn't be hard. But when you ship it to production, there are a lot of different problems. Like we didn't anticipate a lot of things with lightning, shaking of the hands, like a lot of weird borderless tables, etc. And now the default answer, which is also very good, especially with some new research with synthetic like GANs and synthetic generation, like usually default answer for this, we just need more data, like more representative data. But that does not scale. So, for example, and maybe this is a good one I can explain, like if I task you with creating a model which will distinguish pictures of cows from pictures of camels, you can build that model end-to-end in probably minutes using some large model existing, you fine-tune it a bit and you have. Now, often, models can also be lazy. Like in my talk, I will go back and forth between how ML is amazing and how we have a lot of problems, so I hope I will strike the right balance, but often ML models can be lazy. What I mean by that is, in most majority cases, if I give a picture of a camel in a forest to your model, it will predict as a cow. Why? Because like a lot of time correlation causation. Like cows are usually on the field, there is grass, there is green scenery, you have camels, there is sand, yellow scenery. And this is amazing. Like even if I give to a 2-year-old child a picture of a cow riding a spaceship in space, a lot of weird things going around, that child will for sure say it's weird, but it is a cow. But we are still not able to do this for models. Now, there are a lot of other things here that from research which are pushing the boundaries, like from knowledge transfer, now these large-scale models. But still, this generalness and robustness is very tricky. And why I'm saying this from the perspective of user experience, because your model will fail. The question is how much, not if. And from user perspective, you need to build the user experience so that user is in control. In this particular case, as you can see, it's not image to table. You have a step where we highlight the bounding box. We have a step where we highlight the low confidence cells. There is also a picture showing where this came from, and then user can correct, and then you have a table. And this is very easy, like productivity. Like in healthcare and other things, is much more harder. And the good thing about this user experience is also that essentially you have humans in the loop. So often domain expertise will not help. But in this case, you have users in the loop. Essentially, user is labeling data for you. You can learn from that. Now, of course, there is compliance, boundaries, retraining, and everything else from privacy and security. But in this case, you have human in the loop who will help you improve, but also they will get benefit of improving their own experience. Second example I want to use is Microsoft Editor, where I want to talk about data. So first of all, Microsoft Editor is a intelligent writing assistant, like helping you write your documents or emails or presentations. And it means like from foundational things like spelling and grammar, all the way to text prediction, document summarization, and in this case that I'm showing, rewrite. So on these examples, you can see that editor can offer you different rewrite suggestions, versions of your sentence or paragraph, so that maybe it's wordy and you want to be more concise, or maybe the tone, you want to rethink your thoughtfulness of the tone, if you're like too aggressive maybe in your email. Now, when we say AI, we often mean big data. But that is not always the case, because also we need to make it work for examples where we have small data. In particular examples of rewrite, we are talking about, or in general writing intelligence, we are talking probably about language scale. So there are 7,000 languages out there in the world today, and languages spoken by people who have less access to technology, you have only small amount of data and you want to be fair, so you want to make them work for those languages as well. It's much, much easier to build this for English or any other like common language. And there is also other aspect, like data is very, very odd thing, because machine learning can amplify a lot of problems that we have as a humanity, which model infers from data. In case of rewrites, we don't want to produce bias in our data. We don't want to be offensive. Essentially, any kind of toxicity. What that means on the ground is that, okay, first, always default, we can change the data, remove the bias from the data, but that's extremely hard problem, and again, not scalable, because what we thought is offensive like 100 years ago is different from today. It will be different from 100. Every person is different. So we can't generalize these things. There are other things we can try to detect if sentence is potentially biased and don't show to user. There are a lot of other things that we can do, but maybe this is also a good point for me to land that all of these features that you see or any other AI feature, we are engineering the hell out of it. So it's not one big model that rules them all and does end-to-end mapping. Essentially, it's still an expert system. Just there are not rules in the vertices. All of the vertices are deep models, but still, it's a huge system. And the third one, which I want to use, is related to point that I want to make for metrics. So this is Microsoft Designer. It's another intelligent assistant for your writing, which helps you create beautiful, polished, concise formatting documents or presentations without any desired skills needed. As you can see, under the hood, we are essentially running a lot of document understanding, and we can produce these recommendations like pull quotes or whatnot. Now, metrics is an interesting beast. So usually you train a model, you have, as we said, like some benchmark test set, then there is a precision recall. And you have like 99 and we celebrate, open champagne, everything is crazy. Then we ship that to production. Then we offer these suggestions to users and we see maybe only 10% of users are accepting. So what's happening? So essentially, the important thing is to know is that what we test offline, these metrics, they're not correlated with human needs or jobs to be done by users. In our case, we are more, for example, tracking something we call kept metric. So out of all suggestions that we offer to users, how many users accepted something? Essentially, we are interested in task completion for user, not like time spent. And this is different between like love and possession. So essentially, kept rate is on a more abstract level, saying that quality of the model is not determined by benchmark test, rather by user behavior. Users are doing that for us. They're the judges. Now, this is also an interesting example. Why? Because I said we can have a benchmark data, but in this particular case, we don't have. Design is totally subjective. Like OCR, it's not like everybody, we can agree this is number 13, and nobody will say, no, it is 18, and then convince us to that. But this is highly subjective. So you don't even have a data. So how this works usually, we create some model, which hopefully is working for most of the people. Then we ship it to production, and then we learn from user behavior. As I said, especially in this case, it's even trickier because it's subjective. So we need personalization on every level, meaning that each user is different. And personalization usually means either you have very, not that rare model per user, you usually have different signals per user, like your previous behavior is an input signal to the model, not only a text, or maybe some parameters of a model are different. In any case, this means that we are continuously, when you ship a model, it's only a beginning. You need to iterate, you need to work between like both design, engineering, and applied science, we all need to work together to improve and make this work. And there are also a lot, don't let me get started about engineering complexity, how we deploy this to, like, for example, clients, how we keep versioning, how we reduce cost, because this is ridiculously high cost of running these models. So I will not, of course, go through all of these boxes, but hopefully it depicts that iceberg and why that iceberg is so damn deep. And again, research is doing amazing things for each of these boxes. Just the problem is when you ship to production, you need to connect all of these boxes, and then the error aggregates. So, and this is just one side of the coin. The second side of the coin is, up until now, we talked more about like technical problems, but there are also a lot of non-technical challenges, and I will just briefly go through them. First one is that we have decades-long experience in building software development products, and AI is completely different, as we saw. There are a lot of uncertainties. There are a lot of like even technical feasibilities in question. We need to have it iterative. Like we ship something, we need to improve. We need to have humans in the loop. So the life cycle of AI project is completely different, and we still don't have the right processes or procedures how to do it. Then there is a change management. This means essentially that any disruptive technology like AI needs to take into account how will user adapt, organizations. This will change, on one hand, how users do their work, what's the meaning of their work, tomorrow probably what's the meaning of their life. So this change management is very important. And finally, there are a lot of projects out there and products where success depends on the team and team culture. And AI is one of these examples. You need resilience with your team. As we said, we need team to work together across roles and together. And you need essentially growth mindset, meaning like you want to have a team which is learn it all instead of know it all culture, because things are changing at very fast pace. Okay, so up until now, we talked more about like large companies or bigger research where you have a lot of funding to hire, to build an AI product, to hire data scientists and everything. But there is also, on the lower scale, like small businesses equally, if not more important. But a lot of challenges that we mentioned, as I said, small business doesn't have money to hire engineering team to build something. It doesn't have that much big of a data to do it. And each small business is different. Like each bakery is different from the second bakery, different menus, different people buying there, different behaviors of those customers, different ways of tracking the data, etc. So collectively, all bakeries are huge, and they could hire a team, build all those solutions for them, but still each of them is different, and it's hard to make it work. And this is known as AI long tail problem. It means that things like product placement, demand forecasting, any of these problems which are solved by AI by large companies does not work, and none of these things small businesses have on their disposal. So this chart essentially says if we order all the AI projects or potential projects and sort them by decreasing order of value, we have probably ads, web search, e-commerce at the beginning, and all the way on the other hand, and we have these millions of these smaller problems. Still, research is doing, there are some great research happening in this space as well, something that we denote as low code or no code AI. And this is the abstractions level I talked about on the initial slide, is that using only data and probably labeling, everybody can build a model for their particular needs. And we are constantly moving the boundary what's possible. This example, one which is very stable already, where, for example, you can automate some of your inventory process. You only need to be a tech savvy person, not any deep understanding of mathematics or machine learning or software development. And essentially, when I think about AI, I also think about AI literacy. And what I mean by that is, like hundreds of years ago, we as a humankind saw that, okay, if everybody can read and write, we'll be all better, right? It's not only like priests and monks or what was happening back then. So similar is for AI. Like today, it's in the hands of most like large companies, large research centers, and similar. But we will have much better future if everybody can build their own solution. And now moving to the third part of my talk, the last one, is to cover in more excitement aspect, is this trend of large scale models, which will help us solve, hopefully, a lot of these problems or move us to the right direction how to solve them. So in short, large scale AI models are a new paradigm in AI. And let me first start with a few examples just to depict what they are. So here on your left, you have what GPT-3, like OpenAI generative text model, created based on my input. So I essentially wrote the sun rose over the beach as the waves soothingly rolled, and then this sentence completion and additional sentences what GPT-3 model generated. In the middle, we have a DALL-E illustration, which is another OpenAI big model, which, based on my input, generated this image for me. So this is completely auto-generated. And finally, this is an example of Nuva Infinity, Microsoft research model, which takes this picture as an input and essentially creates video sequence with this image as initial frame. Yeah, before I move on, I just want to stop here for a moment because, like, we as a humans, we really quickly adapt to new things. So I just want to stop for a second and say how mind-blowing this is, that we can have a model which will generate, in this case, paragraph. It can be the whole document, or even, like, remember that cow riding on the rock, etc., etc. DALL-E can generate that for me in a second. So it's just ridiculous, but I think we are just, okay, this is all news, like 2 years ago. So this was wow, and this is example, just again, very quick one. So this is OpenAI Playground, where, as you can see, I did enter the chat between customer and the bank call center representative. Then there is a chat where they talked about credit card benefits and options, and then the client asks some explanation of particular acronyms and asks for email follow-up. So the red thing marked with red is what I wrote. So I essentially talk to GPT-3 as a person. I said, here is the chat. Then I pasted the chat, and then I say, write an email follow-up. And then the green thing is what GPT-3 created. I don't know if you can see, but it got everything right. It extracted the email, the name of the person. It explained that acronym. It listed all the benefits. So this is that low code, no code. So this is how can you speed up, for example, this part of your process when you follow up with your clients in email, because this is goddamn good email. Like Turing test will fail this for sure. Like, is this written by human or not? Like Turing test, it's extremely easy. So we're also saying large, and we say large, we mean large. So this is a graph of how many parameters these models have. It looks linear, but it's algorithmic scale. So we are entering thousands of billions of parameters, and for comparison, our brains have around 80, 90 billions of neurons in the brain. And this trend will continue, not just in terms of parameters, but in terms of different kinds of dimensions, like for languages, like from monolingual to multilingual, or for unimodality to multimodality. The models that we saw were text, images. Multimodality will be much better. And interesting trend with these large-scale models is that before, when like with deep learning models that with call, which was also large but not this large, they're also good. But at that point, they were more towards direction know it all but don't understand it all. And with this, we have a bit different trend. We are still not there yet, but there is a very interesting things happening around this. So the good question is, how are we able to generate these large models when we have that data labeling bottleneck? So the trick is that there is something called self-supervised learning, which essentially is saying that you can use raw data to train these generalist large models. As you can see in the example of this sentence, you can get a sentence, mark some of the words, and then train a model to predict those marked words. Or you have a video sequence, you mark a frame, and you want model to predict that frame. So in this case, you can scale data to any sense of like anything is possible that you have approached. So for example, I think GPT-3 was trained around 500 billions of tokens, meaning these words, and Wikipedia has around 3 or 4 billion. So this is 2 orders of magnitude larger. And the second thing is transformers. I will not go into this, but this is the state-of-the-art architecture for these large models. Essentially, it boils down to that they have 2 parts, like encoder and decoder. Encoder takes the input sequence, compresses it into some vector representation, and this representation is very important because that encoder essentially encodes the essence, the meaning of that sentence somehow, and then the decoder can use that vector and generate the text, the image, or what's on the output sequence. So I think this is said by Jan LeCun, one of the top researchers today. The self-supervised learning is dark matter of intelligence. As I said, labeling was one of the bottlenecks before. We are skipping this bottleneck today. But here's the thing, like, we as babies or children, like, we learn a lot of things from observation or maybe with playing with objects. So, for example, we learn that if you touch something hot, you might get burned. Or we learn that like glass is a kind of liquid container, and if it has hole in it, it lost its purpose, etc. But nobody explains this to you. Like this is what we call common sense. Like a lot of things are common sense. We can talk about, is it nature versus nurture, how children learn that, is something in DNA, etc., etc. Now, with this self-supervised learning, one can argue, I as well, is that one way to describe the intelligence is predicting the future. If you have some past experience, however you are learning, but then you predict the future. What that means, as we saw in examples of text completion, image generation, like next frame, predicting next word essentially means that cognitive intelligence. Like we know to follow the semantics of our thoughts and even generate new thoughts based on that. Similar for videos, when you mark some frame and we predict that frame, like essentially we are predicting future. And I can argue that that essentially means that we understand the 3D world. Like if you close your eyes for a second and open them, you will not expect me to be above your head holding for chandelier. You just know it's ridiculous and it will not happen. You just know that it will be very odd if I now started talking about how to make croissants and what you need to learn. You will just say, what just happened? Why is he talking about that? So this common sense, like predicting next frame, next word, leads us much closer to what intelligence is and what common sense is. And there is also this, as I said, like encoder, decoder kind of thing. Essentially compression. One can also argue that compression is intelligence. Because if you want to compress something, you need to learn the rules. You need to learn the essence so that you can extrapolate from that compressed file. Like in mathematics, if you just learn to solve all of the problems from your textbook so that you are prepared for exam, that's one way to do it. The second way is that you understand the material, and then that you can solve basically any problem, even if or not in that book. So with this, we're much closer to a lot of things. And how just to paint a picture why I see we are much closer, we talk, for example, in case of editor, like the writing assistants, that we can have bias, toxicity, offensiveness. I can imagine very soon that we can just say to these big text large models, like, rewrite this sentence to be more concise and don't be biased. And the model will know what that means, what bias is, maybe not what bias is for me, or maybe it will know also to whom I'm sending that email and what can be offensive to them, and just solve that problem. Okay, to sum up, like we started the talk with, like we had like cloud first, mobile first, and now we are in AI first world. And how essentially, as on the slide, there are two types of projects, one that use AI and the ones that will use AI. Unfortunately, the iceberg today for moving a happy path solution to production at scale that works for humans is very important. We talked about some technical, some not technical challenges. But again, this is for products, AI products. Then we have a lot of like different industries that should also benefit from this, but they're too small. And then we talked about democratization and importance. How will that help us bridge those gaps as well? And finally, as I said, I wanted more to land on more optimistic kind of view, is that with some of the trends in the research, we are much more closer to bridging these both of these gaps. So I hope I didn't disappoint, as my talk was not, these are the 10 things that we need to solve in next year and will be great. But hopefully there are some learnings here and some excitement and some learnings that you can apply in your day-to-day work as well. Now, let me leave you with one last thought. Like 10 years from now, you can say one of two things. You can say, remember that day when we decided not to infuse AI in our projects and how bad that decision was. You can also say, remember that day when we decided to add AI to our products and how awesome that decision was. So I don't know what you will say, but just know that that day is today. Thank you.
We have a couple of minutes for questions. So do we already have some questions? Yes, please. Microphone.
All right. So thank you for your talk. I have one which is probably theoretical, but I'm curious about your view. So you said that right now we have like deep neural nets which already have like way more connection than human brains do, right? Is that? And yet, still, we can't distinguish a cow in the space from whatever, right? So do you think there is something more to human intelligence that we don't know about, or is it something that we are approaching it wrongly or something?
So yeah, I don't have the answer, of course. So yeah, we are approaching. When I say we are approaching, we definitely see that trend, like that. For example, that example of generalization in robustness. We are seeing that we are reducing that gap. But what we need to achieve is different. And there is also even a lot of differences. Like AI today, it's much easier to do cognitive like aspects of human intelligence and much harder to do things like in real world, like robots picking up some fruits. It's much harder than cognitive aspects. We can talk is that about the data or things like that. But yeah, like today, realistically, we are still not able to move that needle. And one of the things is also that explainability, I think was also mentioned in the previous talk, is that we still don't know exactly what's happening. Like we see that bigger data bridges some gaps. We see that different kind of architectures are bridging some gaps. But still we don't really understand how it works. So I'm sure that definitely, I hope that transformers as self-supervised learning will be old news in 5 years. I hope, and I'm pretty much sure it will happen. Now, what in addition should happen, it will be interesting to see. Now, there is also a lot of research in the healthcare that we can much better understand our brains, but also someone can argue like, do we need like simulating human brain? Is that the best intelligence path to go through? Or we need even to do something besides human brains and just leapfrog that all the way out. So philosophical answer, but yeah.
A perfect one, actually. Thank you. I also, do we have other questions? I would have one more if we don't. Do we have anybody else? No. I'm just curious. So basically, you're shipping products to like billions of people, right? Like, I'm just curious, what's the, so you train it, you get a perfect, whatever, like, I don't know, the results and whatever. So what was the funniest complaint you actually got back from a customer? Or the funniest or the most interesting instance of a problem you observed in real life?
Yeah, interesting question. Yeah, so as you folks saw, like the way we build models is always to have this loop with the customer, like either implicit or explicit. But for example, all of these generation kind of models, like text generation, like however we think that user will write, like how to write a document or how to rephrase the sentence, like usually it starts in following way. Like users needs to build credibility. Like time to wow is easy, in a sense. Time to value, it's much harder. So initial examples, the funny thing is that the way, for example, the way doctors, like the more professional kind of workers, build the confidence in AI, they ask for explainability, as we talked about. They just don't want to, probability of this pathology is that, they want to understand why. And they give, for example, real examples. Like enterprise is usually giving, okay, I need to write this spec, and here is the example, and I want to write that. Now, for example, when you look at the consumers have different kind of approach. They want to build trust or understanding what's happening in the model with just weird things. As I said, like in enterprise, like for image generation, somebody will probably they're writing a document about like sales, some highlights, and they will write people celebrating something. But consumers, they will just try funny things, and they will poke, they will try to hack it and understand where the error. So all of those like cows riding on rockets, that's happening. So different kind of user bases have different kind of approach into trying to, the goal is the same. They want to try to understand and build trust into the model, but they are doing it in totally different ways.
Interesting. Thank you very much.
Any other questions? I can't see it. I have one small question. I mean, I was watching the image and the video created on the beach and the sun and everything. And the one thing I really disliked is it was too perfect. It has nothing to do with the real life. Same thing is with the email that was done by AI. I can see that it was written too perfect. So I don't want to communicate with AI if I'm exchanging emails. Or in that case, I'll leave my computer to exchange emails with your computer, so there's no communication at all. So is one of the problems why AI may be failing when it comes, when it is introduced to humans to work along with the humans, the fact that AI is too perfect, it's not human at all?
It's an interesting question. So first of all, yes, you can change the input in a way, and even that today works to some extent very good. You can maybe say, write the email like I'm 10 years old, and it will do it. It's solidly good. So in theory...
No, but that's a stereotype. Because there are 10 years olds can be quite different. I mean, some of them can write better emails than me.
Yes, no, I totally agree. Yes,
many of them.
As we said, like we generalize from the data, and the first thing that you will get, for example, in that way, will be stereotype kind of what 10 years a child would write. But as you use your application, it will become more and more human-like to you. Like if you start using these kind of models for the first time to write the whole email for you, I will probably receive that email and say, you probably didn't write that email. But 10th email that you send, I will probably not able to make distinction. Now, the tricky part to your point, we need to make AI coexist with humans. Like that exchange that I have a chatbot, you have a chatbot, it's meaningless. So idea is here more to steer into direction that you as a human are focused on essence, and AI is just helping you with either automation or some tedious tasks or shaping your thing. Like I'm not designer, for example. I don't want, and I don't know how to build the beautiful decks. So I want AI to help. Now, where is the threshold? That's a good question. It's up for debate. Probably somebody will have lower threshold, somebody will have higher threshold, and we, as we said, like we as a humans need to be judges of that.
Okay. Any other questions? If not, Andrea, thank you.
Thank you.
For this great speech. And